Hey everybody, welcome back to a new video. Right here I have the Bluetti AC300 using the new B300K battery. On May 20th, 2022, almost 3 years ago, I launched my first video on the Bluetti AC300. It's been a long time. Now when Bluetti launched this product, it was a flagship model with all the latest and greatest features, and fast forward to the end of 2024 and this still packs quite the punch, especially with the B300K battery that drops the price significantly. For example, right now this is at the lowest price I've ever seen. If you check out Bluetti's Black Friday sale, this is priced at $16.99 or only 61 cents per watt hour. Now the main purpose of this video today is to determine if this power station is relevant or not. Now you guys know that my power station videos have changed quite a bit over the last couple years. I do much more extensive testing, and the first time that I tested this, I didn't get to do any of those tests. So I'm excited to test that out on this newer power station. Now I did ask Bluetti to send this out so I could retest it for you guys. I get a lot of direct comments and emails asking me to test this because the price is so low. So hopefully by the end of this video, you'll have a good idea if you'll want to purchase this power station or not. So let's jump into the fun portion of the video where we actually do testing on the power station. Now, most of my new tests revolve around the AC inverter, so we'll be starting there. Now, this is a 3,000 watt continuous or 6,000 watt surge inverter. Now, there are multiple outlets that you can connect your loads up to. For example, you have a bunch of these 20 amp connections, and then you also have this 30 amp connection where you can connect up your larger loads. To turn on the AC inverter, you just push this AC inverter button, select on, and it turns on, and you can also do that through the Smart app. We'll be testing the continuous output to see if it can handle that and how loud the fans are. We'll be also testing surge loads on the AC inverter. We'll be testing the UPS cutover using my oscilloscope and many other tests. Let's jump into it. First, let's see how the power station performs under a max load test. I started by setting up a 3,000 watt load on the inverter. After the test had been going for a few minutes, I moved my camera over to check the output on my oscilloscope. It was showing a really crisp sine wave output, and I measured 121 to 122 volts at 60 hertz, even with the power station under peak load. After about 10 minutes of running that 3,000 watt load, the cooling fans were up to full speed. I measured 44 decibels with my sound meter from 3 feet away. I even put my camera right up next to the power station to demonstrate how quiet they are. Next, I measured the air exhaust temperature with my thermal camera. I only saw a peak of 98 degrees near the fan exhaust ports. The AC300 has massive internal heat sinks, and they do an excellent job keeping the components cool. My stopwatch soon hit the 15-minute mark, and the power station passed the max load test without shutting down the inverter. How many more watts will the inverter allow you to pull before it overloads? I turned up the load from our previous test till it got up to almost 3,800 watts, and the inverter ran that larger load for about 30 seconds until it finally shut off from being overloaded. So it's good to see the inverter does give you a little headroom when pulling larger loads. So in the next section of the video, we'll be testing the surge capacity of the AC300 inverter. Now I have a few different inductive loads here. I have a 10 amp air compressor, a 12 amp vacuum, and a 15 amp table saw. And this test is to see if they can run it and how many amps they pull. For example, right here I have my clamp meter set to inrush mode, and we plug in each one of these appliances into that cable, turn it on, and it will measure the inrush current. So for the first test, I have the air compressor plugged in. Keep an eye on this portion of the screen, it'll display the current. 3, 2, 1. So you can see it pulled 22 amps on startup, and it did not have an issue starting up the air compressor. So in the next test, we'll be powering up this 12 amp vacuum. Keep an eye on the screen. 3, 2, 1. So the vacuum pulled a little over 35 amps and the inverter had no problem starting it up. So next we'll be testing the 15 amp table saw to see if it will turn it on. 3, 2, 1. Wow guys, 42 amps when that saw turned on and it still powered it up. So for the final test, we'll be attempting to power up both the saw and the vacuum at the same time. I have them both plugged in and the meter's ready, so let's see what happens. Okay, so the saw and the vacuum at the same time. 3, 2, 1. Okay, so we pulled a little bit more amperage at 45 amps. Now it did take a little bit longer to start these up versus the previous test, but we did not overload the inverter. Both the saw and the vacuum started up at the same time. So with that final test, we pulled almost 5,500 watts through the AC inverter. So if you are looking to power up large tools or other appliances, this handles surge load really well. So in the next section of the video, we'll be testing the UPS cutover for the Bluetti AC300. When I originally reviewed this power station, I did not have an oscilloscope that could record the actual cutover time, so it'll be fun to test it with this new oscilloscope to see what actually happens. It's advertised to be 20 milliseconds, so let's find out the actual speed. Now some of you may be wondering how UPS mode actually works. Well, right here you have your AC input. It is passing power directly out to these appliances, so my desktop workstation, monitor, and studio lights. But when it senses the power going out, it immediately swaps over to the internal inverter within 20 milliseconds to keep those loads running. Now to demonstrate that, if we look closer at the screen, you can see 180 watts coming in from the grid and 175 watts going out to our devices. So we're getting power directly from the grid going out to our loads. Now in order to make this more realistic, I put a stress test on this PC so we can max out the internal power supply. So when we cut out power, we can see if it actually stays on. So measuring the UPS cutover in 3, 2, 1, record. So on the screen, you can see the actual cutover. So this point right here is when it cut out, and this point right here is when it resumed. So the distance between these two cursors is when we kind of lost power. You can see that it didn't really lose power except for one little piece right here, but this distance is 9.6 milliseconds. So it does perform very well as a UPS. Now during that first UPS test, the computer was still running. So let's do a couple more just to verify that it keeps the PC running. So second UPS test in 3, 2, 1. So just a teeny flicker of the lights, but everything's still running. Third and final UPS test, 3, 2, 1. So the same results. The PC is still running, and we just saw a very faint flicker with the studio lights. So in the next section of the video, I want to use my outlet tester here to see if this is wired properly and if it has an open or floating ground or a bonded ground whenever you have the AC inverter turned on. So we'll go ahead and plug this in. So right here you can see that it has an open or floating ground whenever it's not charging from the wall. So I've connected up the AC wall charging cable, so we're charging from the grid, and you can see we still have an open or floating ground. So in order to get a bonded ground, we're gonna have to use a bonding plug like this. Basically you just plug this in and it'll give you the proper wiring. So this performs just like a gas generator. How much usable capacity should you expect from the Bluetti AC300 inverter? The B300K battery is rated for 2,764 watt hours of capacity, and when draining the power station down until the inverter shut off, I measured 2,410 watt hours of usable capacity. This result is 87.1% of the advertised capacity and is definitely a respectable result above my goal of 85%. Next, how much power is used as the AC inverter is enabled and sitting idle? I started with the power station at 100% state of charge and left the inverter turned on for a little more than 12 hours with no load, and when I came back it had dropped down to 83% state of charge, meaning the inverter used 17% of the battery over a 12-hour period, or about 1.4% per hour. This idle power usage is quite better than the first AC300 I tested a couple years ago. Now, does the power station inverter create any noise or interference? I measured about 1900 millivolts of EMI using my dirty electricity meter, so the inverter produces some measurement of EMI, but is that level actually audible? Plugging my guitar amp into the inverter, this is what it sounded like. So comparing the inverter output to wall power demonstrates that the AC300 does not have any audible noise on the inverter, so it should work well for powering audio equipment. Okay guys, it was really fun to run this power station through all those new tests. Now I did notice a pretty big difference between this model and the first model I tested. For example, the fan noise under max load, the fans used to be around 54 to 55 decibels, and now they are at 44 decibels. So they have definitely upgraded the fans in this unit. The other thing that I noticed that was pretty big was the actual idle power usage. When we had the AC inverter turned on, instead of using over 2% per hour, it's actually down around 1.4% per hour now, even using a smaller capacity battery. So it seemed to be more efficient as well. Now, what else did we learn from that testing? Well, as we discharged the power station, we got a little over 87% of the advertised capacity, or 2,400 watt hours. As we did the UPS cutover testing, I measured 9.6 milliseconds, meaning this will work really well as a uninterruptible power supply since it's under 10 milliseconds. And finally, when we tested the surge capacity of the AC inverter, we pulled over 45 amps on startup, which is a little over 5,400 watts. So if you're wanting to power large induction loads, it should work well for that too. Now, another main benefit of the AC300 is the multiple DC output options. For example, right here you have a 12 volt 30 amp output that's good for almost 400 watts. And this will allow you to feed a 12 volt fuse panel in your camper van or in your RV. You also have this really cool 24 volt 10 amp output to power 24 volt devices. Well, you can also plug in your smaller power stations to this cigarette port here and charge them super quick. I showed that in my first AC300 video. And you also have a variety of USB ports. Let's take a closer look at these. Now, using my USB tester, I've connected to the 100 watt power delivery port, and you can see that we are getting power delivery 3.0 at 100 watts, which is right around 20 volts and 5 amps. Connecting into the fast charge ports, we are seeing quick charge 2.0 protocol at 12 volts. For example, 12 volts, 1.5 amps, right around 18 watts of power. So those ports work properly. Now, what about the final USB ports? Well, they're rated at 15 watts, 5 volts, 3 amps, and we are seeing around 10 watts from these. So dedicated charging protocol 1.5, and we're getting almost 2 amps. Now guys, the AC300 is a DC powerhouse. If you're interested in seeing how both of these outputs perform here, please refer back to my original AC300 video. Not much has changed there. And I just wanted to show you guys this newer testing option with my USB tester, as that's not in the original video. Now, in my last test on the power station, I want to do some solar testing. When I originally tested the AC300, I didn't have much solar to max out the 2,400 watt input, and now I have many more solar panels. Now, the AC300 was one of the first power stations to have dual solar charge controllers. Like I said, it takes up to 2,400 watts input, and that's via 2 separate charge controllers that allow up to 1,200 watts and 150 volts input. Now, through my testing, I actually used the AC300 initially for about 6 months as my main power station, and the solar worked flawlessly, so there's no issues with the solar being connected 24/7 or anything like that. But now that I have more solar, I want to see how close we can get to the 2,400 watts input. Now, just be aware, it's a little bit later in the year, so we're a little bit close to winter solstice, so you can't expect a ton of solar right now, but let's test it anyway. Okay guys, let's do some solar testing on the AC300. Now, there are 2 separate solar arrays that I want to test on this. The first one is this one on top of my carport. It's a 1,600 watt array. There are 4 400 watt solar panels wired together in series. And then this one right here is a 1,200 watt array on top of my shed. Now, it's a late fall day. It's around 60 degrees with just a little bit of haze. I apologize for the wind noise. It is a little bit windy today. Hopefully the camera's not picking that up. But I'm not expecting full power from both of these because the sun is so low in the sky. These are not angled properly. But let's go ahead and connect them up and see what we get. So I've just connected up the first solar array. You can see we're getting 1,130 watts input. And you can click on this and break down to see what's actually happening. So you can see we're getting around 118 volts DC input and around 1,125 to 30 watts. Now, because this has 2 separate solar charge controllers, you have the ability to connect in 2 different solar arrays at the same time. So we have the one connected in. Let's connect in the second one. Basically, they're going to add up the power together to charge the power station faster. So with both of those solar arrays connected up, we're now charging at over 2,050 watts input. If we click on that, we can see a breakdown of each of the solar arrays. So on the smaller array, we're getting a little bit over 900 watts, and on the larger array, we're getting a little over 1,100 watts. Now, this is what the solar charging cable looks like for the AC300. You have 2 MC4 connections that are labeled DC1, and then you have 2 that are labeled DC2. And so you basically connect up each solar array to the corresponding connectors, and then it starts charging. Now, some of the newer power stations that are coming out now have one large solar input that goes up to like 450 volts. Now, it's nice to be able to get a massive amount of solar input, 4,000 or 5,000 watts. However, there are just a few disadvantages to that. First off, when you have an array that large, it usually requires 120 to 130 volts to start the solar charging. And you can't get that with a few solar panels. So this one here, even though it doesn't allow that much solar input, it does allow solar panels to start at 12 volts all the way up to 150 volts. So you can charge with smaller solar arrays. Now the next benefit of having two solar charge controllers allows you to separate your arrays out in two different sections. For example, my carport and my shed roof, if I had that tied together in one large array in series, basically as I start getting shading in the afternoon, I would lose most of the power from that entire array. However, because this has two separate arrays, as I get shading on that carport, my shed roof still puts out maximum power. So there are some advantages and disadvantages to each option, but if you have a smaller solar setup, it's kind of nice to have the two separate charge controllers, especially if you're going to be dealing with partial shading. Okay guys, with all those tests done on the AC300, I also want to see how this does in my newer power station grading system. If you remember when I first released the AC300 review a long time ago, I had a power station grading system, but the rules weren't that strict. And since I've upped it to the 2.0, it's much more strict, and a lot of the older power station grades have really suffered. So I want to see how this one does, even though this one's been around for 2.5 years or so. How does it actually do on the 2.0? Well, let's find out. Now up on the screen, you'll see my power station grading system 2.0. Looking closely, you'll see there are 20 performance metrics required to get a perfect score of 10 points, each one being worth a half point. These are either important features or performance requirements that my viewers are looking for. The Bluetti AC300 performed really well in the testing. It only missed out on one requirement. It did not reach 85% of the DC capacity when tested. It got a final score of 9.5 points, or an A grade. Wow guys, I was not expecting it to do that well in the power station grading system, especially because of the date of this power station. However, I was thinking about it. This was kind of Bluetti's flagship power station, and it had all the features that other models didn't have. For example, this has the dual solar charge controllers. This has the fast UPS mode. This has fast internal AC wall charging. Do you guys remember that power stations that long ago used to have external power bricks to charge them up? Well, this is one of the first power stations that actually used AC charging built into it. So they kind of set the bar, and it's taken a couple years for other companies to catch up. Now, I will say this power station is definitely not perfect, and it's not meant for everyone. And there are a couple things that I want to discuss that are kind of disadvantages to it. For example, the main head unit here, this top section, doesn't have any batteries in it, and you can see that it is just massive. So that's one of the downsides, is that it just takes up a lot of space. Now, I did notice that they have some massive heat sinks in here, so they are utilizing that space so that the fans don't have to run, and all the internal components do stay fairly cool, but it does take up a bit more space than other power stations that offer this much output. The other thing that's a disadvantage is the actual connecting cables. You can see that they take up a large amount of space on the side of the power station. Now, it does help if you put a little twist into it so that they kind of tuck in a little bit closer, but I really would love to see like a 90-degree adapter for this power station and the AC500. I feel like they could put out a new cable that's just a little bit shorter, and then maybe use the longer cables for a second stack of batteries. Now, another disadvantage that I want to mention with this particular combo is the fact that this now has the B300K. The B300 is no longer in production, and with that you lose the additional charging input and the DC outputs that came with that battery. So this is a little bit smaller capacity, and it's a lot cheaper, and so that's the route that Bluetti decided to go with. Maybe they did a bunch of market research and found out that most people weren't using the DC output or the additional charging input. I know that in my particular setup, I never used those on the expansion battery. I always used them actually on the power station up here. So they probably opted to save that money and pass that along to the consumer to give you a much cheaper price. But I have heard a lot of people saying, hey, I actually really liked the B300 battery with its outputs and additional charging input, so it is kind of a bummer if you wanted those features. So that was a brief overview of the advantages and disadvantages of the AC300. So you guys will have to let me know what your thoughts are on the AC300 down in the comments section. I always love to hear from you guys about the power stations that I test here on the channel. Now, answering the main question for this video, is the AC300 still relevant at the end of 2024? And my answer is yes. I still think that this is valid, it's relevant, and it performs well, especially for the price. Now remember guys, they have a special Black Friday sale going on right now. Check out the video description, I'll have a link to it, where you can pick this up for the lowest price that I've ever seen at $16.99. And after that sale, the price will go up, but it's still going to be fairly affordable. Now, if you liked the video, please smash the thumbs up button. I'll recommend a couple other videos that you can check out that are going to be similar to this one. And also, did you guys know that I have a basic consulting service? If you're interested in finding out the perfect solar panels for your power station or any other question that you have, feel free to reach out to me. I'd be happy to answer your question. Thanks for watching, guys. We'll see you guys in the next one.